Hello? Okay. Good morning, everybody. Thank you very much for being here. It's lovely to be in the south for a change as well, which is nice. My name's Terry McCann. I run a company called Advancing Analytics. We are based just over there. You can come along and win some goodies. So we do a whole number of different bits and pieces, predominantly focused around data engineering and machine learning, predominantly on the kind of Microsoft stack. We also have a YouTube channel, which I'll always point people to. We've got about 150 videos up there now, so loads more content like this if anybody is particularly interested. And some more bits about me. So what we're going to go through today is to talk a little bit about how we can think about establishing a capability in machine learning over the kind of next year and moving into 2022. What are some of the challenges that we see, and how can we go about trying to solve some of those? And I'm sure you'll all be very familiar with this quote from DJ Patil, which was that data science is the sexiest job of the 21st century. And so we're going back kind of 10 years since DJ Patil actually said this. And when he sort of said it, it sparked this whole wave of companies starting to think about establishing a machine learning capability. And a lot of them were doing it not necessarily because it was the right thing for them to do, but more because it's kind of what they thought their competitors would be doing. And they all started striving towards this kind of concept of a data science unicorn. And so when we look at the skills required and kind of what we were working with when DJ was sort of saying this, is we were looking for somebody who looked a bit like this. They were experts in statistics, an expert in machine learning. They were better at software engineering than most software engineers, and they were also fantastic at data analytics. And then wrapped up all around that, one of the most important parts is this idea of having a deep understanding of their domain as well. And this, largely became what was known as the data science unicorn, and it's just almost impossible to find. I think I know possibly one, and he's a very interesting character, so, maybe not everyone that you want. So I think when it comes to establishing a capability, what we need to think about is, well, do we need a single person? Do we need a whole team of people like this? Or should we be thinking wider about a kind of composite team made up of individuals who have strengths in different areas who can come together to really form this kind of team? And so what we say is that really we don't need to find a lot of people like this, but what we need to find are people with aspects of this. And you can generally break that down into kind of these three roles. And the thing with these three roles is you'll never be limited to these roles. These roles are constantly emerging as well, so there'll be different ones coming up. But you can kind of start with a data science modeler. This is somebody who's potentially very deep in statistics and deep in machine learning, possibly from an academic or a mathematical background. Somebody who can build out models. Now, the difficulty you have with this role is they might not be well equipped to actually productionize a model. Now, if you can build models, great. But if we don't get them live and we don't offer an ROI on them, it's very difficult for us to then kind of get the funding internally to do the next model and the next model. Or we end up as a capability just constantly rebuilding things. So the option we have there in the middle is the machine learning engineer. They might not be anywhere near on the kind of statistics or have no statistical background. But what they do have is they offer that kind of software background. So they have the ability to take a model and pop it live and then start getting that into a production process. And then the last one on here is our kind of data analyst. Because again, there's a lot of work required in understanding our data and really getting it into the point that we can generalize something that it works well for us and offers us the ability to produce a good machine learning model. So what we like to try and do is when we're thinking about establishing teams, if we work with a customer who have no kind of capability currently, we'll start thinking about where do some of these roles exist? Are they roles that exist internally already? Is there some kind of capable software developers who could fulfill that position of a machine learning engineer? Or do we need to look externally and start hiring for some of these roles? Now, once you have these roles, machine learning can often be thought of as being kind of this thing, right? Now, what we're going to do is we're going to spend a huge amount of time really just kind of bedded in building out our machine learning models. But typically what you find is the picture looks a little bit more like this. This is from a great paper from Google by Scully et al. They're from 2015 now. I've been saying this stuff for a long time. And what you can kind of see here is that, as I say, everybody thinks that machine learning is this, right? A data scientist is going to spend the bulk of their time spent here building out models. Where in reality, that actual process of building out a machine learning model is only a very small aspect of what we're doing. And the rest of our time is spent around a whole load of this configuration. Oh, try not to get things going. You know, we've got all these other key areas that we need to consider in order to make sure that our models succeed in the future. And that's in terms of capturing things like configuration. If we've got a machine learning model and it's built using, say, TensorFlow, and it's built for a particular version of TensorFlow, when we want to deploy that somewhere else, we need to make sure that we're maintaining those same standards, those same dependencies. Otherwise, what's going to happen is we're going to end up with a very problematic deployment. We might deploy it to somewhere else, the dependencies change, and when that stuff happens, things will fail. And ultimately, if it's a new capability, we need to minimize the amount of failures as much as possible so that we can start building trust in their organization that machine learning is something worth investing in. Then you've got the other aspects around here, right? You've got things like data collection, verification, how you do automated feature extraction and feature engineering, right up to how we serve something and then how we monitor it. So all of the areas that kind of sit around machine learning that often get forgotten, but are really vital to establishing that proper capability. Now, there are approaches that you can take with all of these, and you can simplify them all pretty much with a nice, solid kind of data platform. So one of the things we do as a business is we build platforms for customers. That could be a data platform, kind of using the kind of lakehouse style approach, or it could be a machine learning capability in a machine learning platform. And with that, we use a variety of different tools to try to break down some of these key problems so that our data scientists can focus on what they do really well, which is build out machine learning models, and we try to automate the rest of it away as much as possible. Now, I think these pictures make it all look very easy, and there's a lot of work required. But once you get a lot of the kind of automation and bits and pieces down, we can do a lot to really simplify the approach that we have. Everything also gets a little bit more complicated when we start looking at Azure in particular. So as a business, we primarily focus in Azure. We do bits and pieces in the other clouds, but we mainly play in the Azure space. And this is what we've historically known as our data science octopus, as many arms. And once we've built out a model, you know, there's so many different options that we have for actually trying to build something. You've got your kind of key kind of players here in Azure, such as Azure Machine Learning Services, which is a great place to look at when you're trying to enable different personas in your business, different ways of working from your citizen data scientists and your analysts. Somebody who might know a little bit about machine learning, but they might not know enough Python, or they might not know enough R or another language to actually build something. We can still try to enable those kind of users with something like Azure Machine Learning Services, with a GUI way of working, or potentially using automated ML, or process of kind of looping over lots of models to build something new. Then as complexity increases and as machine learning begins to get embedded, when we start trying to tackle some of the bigger, harder problems, those problems that potentially need to go in front of your customers, ones that need to be integrated into your website that require really low latencies, we can start moving to more complex scenarios involving Docker and Kubernetes and scaled out approaches. And ultimately, Azure is fantastic at giving us a variety of different ways in which we can play so that we can try to win at the different scenarios we have. Then we've got a whole variety of other bits depending on if we're building out batch models or building out real-time models. We have a kind of variety of different ways. And what we try to do with companies is help them kind of navigate what's happening here. what is the best options for you to work with? How do we ensure that, what we're building is something that you can support long term? And so you have all these different options, but it comes a lot down to, people, process, technology. Where are your teams currently? What are you currently doing? Where is it you're looking to go? And how can we pick the right kind of architecture that best supports you? So Azure is great, but there is a huge amount. When we start looking at some of the other clouds, the options get much wider. But at least it's a lot of fun, right? We get access to a lot of great technology that we can play with and just kind of see what works best. Then once you started kind of working through, building out a team, picking your first machine learning project is really vital. We've seen this a lot in kind of our customers, where what they've done is they've picked something and it's not quite gone so well for them. And then when they've tried to look at saying, okay, well, what's the next thing we do? By that point, the business are a bit like, well, we tried machine learning and, it didn't quite work out. So we're not necessarily interested in investing our time, investing our money. So picking that first machine learning project is really vital to setting up the success of a capability going forward. And now sometimes when we talk to customers, they want to go down the options of saying, right, well, we know that our best approach that we could take is we want to do computer vision and we want to set up, we've got all these cameras in our warehouse and we want to do automated hard hat detection. And it's like, okay, great. Do you know why your customers leave? And they're like, no idea whatsoever. But we want to do hard hat identification. It's like, maybe we'll look at customer churn first. And we'll think about doing some of these low-hanging fruit, right? So that that we can build out a capability and that we can actually produce something that offers an ROI earlier. So we're getting some return on that investment much earlier. It's just going to, again, set us up for success in the future. Now, the approach that we take, and you can download this from our website, is we use an approach called into what you should think about for actually building a model out. So the middle part there focuses around, what you're actually going to try and build. But the rest asks a lot of questions about, well, why are you actually trying to do this? Like, is there actually any benefit? And then we look at, okay, well, how does somebody do this manually? What is the process? What actually happens if we make a mistake here? Is it, the kind of hard hat scenario where somebody might, end up dying or something through not being able to have that visibility? Or is it the case, that we're losing 100,000 customers each year and we're unaware of it? We start asking a lot of those questions. And then an interesting one, which is often really missed, is like, what is our success criteria? When do we actually stop machine learning? Because, machine learning is incredibly academic and it's a lot of fun. The difficulty that we have is that we can start building out our model and we might get to, say, 80% accuracy. And it might actually be enough for what we're trying to build to stop at that point and say, yeah, okay, we've built something good. But we then might say, well, actually, we could push that a bit further. Should we go to 90% accuracy or keep going and spend more time and more money? And that more time and more money, are we actually offering any kind of return on investment, again, on our process? Or should we stop at that point and move on and look at something else that's interesting? So what we try to do with this canvas is ultimately capture all those requirements. And we might do that for the first model, and we might do it when we try to find a number of different models. And ultimately what we try and do is start building out this kind of idea of a backlog and kind of a funnel of which models will work best. Because again, what we want to do is we want to look at those models which are potentially quite easy, especially for our first one that solves an actual genuine problem. Hopefully something that's fairly low in engineering complexity, because if something's quite high in engineering complexity, there's a lot of moving pieces that we need to get involved to actually get that live, and possibly something that's low in model complexity as well. And ultimately what we start seeing is, we'll have a load of business problems, and then slowly they'll start filtering their way down in this funnel so that we know we've got these potential projects. Of our potential ones, we know which ones are feasible. We know which ones are then ultimately, we know they're good. We know that they've got a good price point. And then we can start actually exploring whether or not we want to build those out. Until the point that we've proved it and we put them in production, and then we're able to offer that kind of return on investment that we're really looking for. And also this starts to give a business the confidence that they can see a roadmap for where we go next. Because the great thing about working with any new business who are starting to work with machine learning is you'll show them one idea and you'll get a room of people and you'll talk through that idea and they go, well, how about extending that to this customer cohort? Or what if we start looking at this part over time? And, oh, Norman in procurement has got this idea that he's been working on. How would we do that? And we start building up these additional use cases over time so that the business have this great roadmap for where they need to be going. And it's one of these things that can then just start establishing that capability and really setting everybody up for success. Now, one of the other things that you can always look at, and there are different ways that you can kind of do this, is the idea of having an operating model. Now, it never sounds like, the most sexy of things, right? Building out an operating model, that's what we wake up for, right? But it's one of these things that kind of sets the tone for how we go about deploying models or building them, when we should stop training. And we start thinking about some of these short and long-term objectives here around stabilizing a platform, understanding who is involved, who from the business do we go and seek for ideas, how do we build out a responsibility matrix of who is ultimately responsible once a model goes live. These are the sort of things that often get neglected, and then when something is live and everybody steps away and nobody wants to accept responsibility for it, then we end up with problems. Then we start thinking about, well, how do we define the kind of roles a bit better? How do we start establishing what we need going forward with all these great use cases? And then kind of how do we grow that relationship? And how do we begin to extend that team into other areas of the organization? And so establishing a model, although it may not be the most exciting thing, it's a great way to ultimately get started. As I say, there are different approaches. You could kind of do this part first and do a lot of thinking up front. Our approach is always to land, find a great model and start building it. And then as we go, start working out some of these points and build that operating model as we go. So I'm pretty much at time. 20-minute sessions are great. We're around, we're over on that booth. So do please come and ask us any questions. And what I would say is that, there's never the right time to invest in building out a new capability in your organization. But we're at that kind of point, we're at the industry 4.0, we're at the same point where we were now with things like Web 4.0. Everything is being accelerated and improved with AI. There's no better time to start jumping on this and establishing that capability. And if you do, make sure whatever you're doing is you're working from a kind of ROI perspective and then going forward to make sure that you gain those successes in your business. So thank you very much for your time. As I said, my name's Terry McCann. I will be over there all day. And thank you very much.